So let me start off with the following. I happen to sit on the FCC TAC, and 2 years ago drew an assignment, and the assignment was from the chairman of the FCC to take a look at when should we retire the PSTN. Okay? And if you think about that, you have what people actually use, what's deployed. Then you have this whole set of rules, laws, and an incredible amount of stuff hanging off this ancient system. And I think what the FCC was looking at is, when do we go literally to a national infrastructure of record that is all IP-based? Okay? So thinking about that, I said, we've actually had IP around since the 60s, ARPANET, things of that sort. And I think it's time to start thinking about what is a network in today's context, number one. And number two, when are we actually going to face the next forklift and maybe plan for it a little bit better? Okay? So I'm going to sort of walk you through some of the thinking that goes into this. And I'm going to really talk about 4 items. The first is the technology that underlies the communications and network world. And it's a lot more than just communications. A little bit about networks and their nature, what the users seem to be exhibiting, and then the world of providers, and I mean that broadly, the service providers, the people who build the equipment, the whole supply chain, the guys who generate the material that we watch, things along those lines. So let me remind you that people sometimes have great insight, and this is a cartoon from 1934. It's Dick Tracy, and Dick Tracy already had a little video. He had his magic wristwatch. It was completely hooked into every piece of information he could want. I think this seems to be the world that we are heading towards, and this was thought up by somebody as part of a cartoon in 1934. Okay. So let me take a fairly serious look, and this is nothing that I suspect anybody in this audience doesn't know. But, we've had the Moore's Law curve. It's fairly famous. People sort of count on it. That curve, in fact, comes from 2 neighbors of Gordon Moore's in Palo Alto, Mr. Livingston and Mr. Blewett, who in fact did one of these curves for accelerators. And they plotted, when SLAC was being built in the early 1960s, okay, what the progression in the highest energy achieved by an accelerator was over time. Okay? And what they found on a semi-log plot, it's a straight line between 1934 and 1960. What's remarkable is that curve has in fact continued to today. And so if you look at something like CERN with the Large Hadron Collider that just did the Higgs boson, it's right on the curve. Okay? If you look under the hood a little bit, what you find is that the technologies, in fact, change over time. You had one kind of accelerator in the beginning, they stopped growing, some other technology came in, and then another technology. And if you look at that field today, there are probably 3 or 4 candidate technologies that continue to take you up that curve. What is also remarkable, when you look at this last move to the Large Hadron Colliders, there were roughly 20 other technologies that had to move at the same time. Okay? You couldn't just magically say, I'm going to do one thing. You had to do many, many things simultaneously. And if you take a look at something like chips, communications equipment, storage, the same is true. So, if you look at the right, what you'll find is, a new record and a new technology had to be developed for how you manufacture large magnets. If you look at the accelerating fields for the RF systems on this accelerator, again, you had to go to much higher voltages before you had breakdown. A new technology for treating cavities to be able to do that. If you look at the amount of data generated from this monster, okay, an incredible storage plant. If you look at each of the detectors, probably the single largest embedded I'd say sort of combined system that's got a little network inside it. It's got processors all over the place. Really marvelous things. Okay, and when you start looking at the basics in this business, you know, it's sometimes very hard to predict what you will actually get, because for CERN to collaborate with its folks, you had somebody like Berners-Lee, who invented the World Wide Web, okay, just so he could collaborate with folks. Okay? And while we may have had ARPANET before, the World Wide Web is what made it useful in many respects, essentially. Okay? All kinds of things come out of this technology. And my belief is that when you invest in basic technology, it's the feed stream. The law of continuity says if you don't put something in at that end, you're not going to get something out on the other. Okay? So if I were to look at things historically and look at the level of progression, I don't know how many of you know that the first railroads were actually horse-drawn. Okay? The rails were laid down to just lower the friction. Okay? So you could go faster on a railroad than you could on a normal roadway. That's what they were built. All the way to today, where you have that maglev train to something like Shanghai. So let's take a look at what actually affects our world. And I would say that there are 6 ingredients, some much more mature than others. But there are really 6 replicatable technologies that we are dealing with. This is what we cook up our meal from. Okay? They're computing, storage, communications, display systems, sensors, and actuators. Okay? And each one of those is actually moving on an exponential path in terms of improvements. Software I put as a little bit different, okay? But I can tell you what you can do with a line of software today compared to what you could do with a line of software 30, 40 years ago, it's a world of difference. I mean, I do remember sort of struggling with machine code and trying to make things efficient, and what one line that I produced could do compared to what I can do today. This stuff, despite its bad reputation, is again on that exponential curve. And what goes along with this is the basics. I mean, it's the science. It's the physics of propagation, interference, noise, things of that sort. It's the engineering principles. It's how you manufacture stuff. But there's a huge ecosystem built all around this. So this is the world that we live in, from which we're going to cook up the next set of meals, essentially. Okay? What is predictable, though, is that those 6 items, okay, are really on that exponential path. Okay? And this is what they behave like. Okay? So if I were to do examples, you know, starting with tin cans, maybe mirrors, all the way to Moore's Law, okay, each of the 6 areas plus software in terms of its capabilities literally are on this path. So I use a favorite example. I've used this before. If I were to take a look at something like the iPhone, okay, it's not a phone really. It's an internet device. It's got incredible storage. Came out with 8 gigabytes of storage. Okay. If I were to have tried to do that phone 20 years earlier, okay, that storage would have been the size of a refrigerator. Probably cost me $100K or so. Okay. Tremendous different world. So not only is this stuff accelerating, for each of these areas you have roughly 20 things that you also have to move forward. Okay? And this is happening. I mean, I'm going to say in all 7 of those areas, the next 1 to 2 decades are sort of in the bag. You see them in the laboratories, you see this stuff progressing, okay? And there are consequences of this because everything becomes cheaper. The factors, the form factors get smaller, and things that you could have thought of that were just not producible, like that wearable device that Dick Tracy had, all of a sudden become easy things to actually do. Okay? And this has, I think, a lot of fairly profound, I would say, consequences for it. So the first one is when I take a notion of a network, we tended to think of these as communications network. And if you were in the Bell systems, it was a communications network for voice to begin with. Okay, data came in somewhere grudgingly along the way. Okay, but I can tell you, in today's world, that's not what a network is anymore. What people care about, what the customers care about is, what will it do for me in the end? Okay, what is it end to end? How is it all orchestrated? And the communications is just one component. It's a component I want to count on, okay, but I want to all of a sudden use in a very different way. So let me give you an example. If I look at voice, this magic thing that we had with phones in the past, lots of wonderful science, echo cancellation, quality, response time, jitter, all kinds of wonderful things that you put in there. You all of a sudden find it's an embeddable, repeatable piece of code that I can use and embed in anything. Okay, I get the New Yorker, for example. The last issue had a poem in it. If I got the digital version, not only could I read the poem, I could have the poem read to me, okay, by the author. Okay? Okay? And boy, it sounded different. Yeah, I don't read it in my mind the same way as it would be actually read by somebody who wrote it. Okay? All kinds of consequences. And what these things mean is we all of a sudden live in an age of much greater complexity. Okay, I don't believe that the science for dealing with that complexity at all the levels has actually been developed. For all the wonderful things we see, we're sort of just actually starting to scratch the surface. Okay, many, many players. I used to have in the Bell system, before the Carter ruling, totally vertically integrated. You could not hang your piece of equipment off the Bell telephone system. Okay, forbidden by law at one point. Okay? All of a sudden, everything that you do has equipment, software, pieces that come from all kinds of sources, essentially. Okay? And there has to be some principles that allow you to assemble those. So, distributed resources, heterogeneity in the extreme, essentially. And yet, strangely enough, it's one of these laws of nature. Things do tend to be hierarchical. Very, very naturally hierarchical, okay? And what makes it work is the fact that you can create loose federations, that you have some long-lived interfaces, okay? And that we really are creating, with all of the software, all the algorithmic science, a much higher degree of automation, essentially. So let me take a look at sort of today's buzzwords, the cloud, and I call it fog because computing has gotten cheap enough. Okay, everything isn't going to be in this huge fortress somewhere tied to the rest of the world. You're probably going to have computing, storage, stuff distributed all over the place. Okay. And I can tell you, having reviewed projects at probably 20 different outfits that build computers, build this, build that, the computer guys are scrambling to put comm gear into everything that they're shipping out. Okay? If I take a look at the guys who used to just build network equipment, they're running as fast as possible to put compute and storage into their devices. Okay? So if I were to take a look at a base station, I'm starting to see designs of base stations that already have computing capability, storage capability, caching capability built directly into the device, essentially. Okay? So a lot of that is happening. I think self-forming applications and services, again, I think the science is a little bit behind the times. Okay? But a lot of academic work in this. I think this is some of the stuff that's coming to the fore. So, when I take a look at something like LTE, the original roadmap, okay, had self-forming networks in there. Well, the guys who designed stuff in today's world were still very leery of anything like that happening. I think it's actually something that will happen. And again, it has a lot of implications for what the connectivity is on networks, how I can send data through multiple paths at the same time and do that reliably, securely, with all the abilities that come along. And therefore, things like mesh and multipath, composability, lots of science, I think that still needs to be done. So, when I said something about networks, and, it isn't just communication networks. It's the same with movement of goods, okay, as it is with movement of bits. I would say the exception is when you're moving goods around, you don't want to shed packets along the way somewhere, okay? But if you were to draw a picture, for example, for the world movement of stuff in big containers, they go to distribution centers, those get brought out to local, local centers, eventually in retail. If you map it, it looks exactly like a communication network, essentially. If you were to take a look at what Amazon is doing, okay, and you look at their whole plant, or a company like FedEx, okay, which, in hindsight, you look at it and says, boy, that was an early cloud company, okay? It's not the fact that they move goods around. It's the fact that they had this super information system that allowed them to tell where the load was coming from, where I should switch the packets and go into this plane or that plane, essentially, okay? An incredible investment in that. And allowing the customer to actually know and track where their stuff was, okay? Privately built, okay? Purpose-built, okay? But basically, this is what I mean by end-to-end complexity. They delivered some value. You could count on this, okay? So when you look at all of this stuff, you have the intercontinental networks growing like crazy. The national stuff for the U.S., I think we have overbuilt stuff many, many times over. Actually, what you're starting to see is that the guys who are the operators are moving things like cell towers into other people's hands, okay? So those can be reused as common infrastructure, essentially, a much more efficient thing to do, okay? Regional, metro, access, this is where the edge stuff starts coming in, essentially. As you go down this, the density increases, okay? And what you're starting to see is that as you come down this, more and more of the goods and infrastructure are actually in users' hands, no longer controlled, okay, by the guys who are the network operators. Okay? And this is why having some form of automatic orchestration makes a tremendous difference. If I look at heterogeneity, still have satellite stuff, always gets killed by something else, but still exists and has utility. On the terrestrial end, wired, optical, free space, wireless. It's sort of interesting. We have broadcasters who, for legal reasons, hold on to their spectrum like crazy right now. Less than, on the average, between 10 and 15% of their traffic is actually broadcast. But there's something interesting there. Okay, with forward error correction, they do something like on the advanced ETSC stuff, 64 megabits in a 6 megahertz channel. Okay, pretty damn impressive. Okay. I don't see anything on the cellular side that does anything comparable. Okay. For business reasons, you can't do it, but you could actually feed and do some kind of, code division, multiplexing, things of that sort. It's actually a very neat communication system. And when you actually start looking at user habits, okay, Netflix, over 50% of all the traffic is the top 20 titles. I may be better at broadcasting them, okay, than sending them inefficiently through the internet. So there are lots of questions of this sort that come up and say, hey, do we really have what we need to have? And then it's integration with all the other components that really matters. Okay? So the other big trend is the Internet of Things. Okay, and I have two things to say on that. And that is, we are in this early, everybody's beating the drum. If I look on the internet, an incredible amount of graphics. So if I look at Juniper, AT&T, Cisco, I think they're putting more money into the graphics department than they are into their science and engineering at this point. Okay, unfortunately. Don't mean to offend anybody with that. Okay. But I can tell you, tremendous opportunity, but not without the basic science and engineering being made solid. Okay, and what you find is this is a game of large numbers. Okay, so you have a spectrum shortage today. You also have tremendous swaths of spectrum that are out there, but there are no electronic goods in those parts of the spectrum. Okay. Which have the performance and cost structure of what you have in the cellular bands and what you have in Wi-Fi today. Okay? Those numbers are so overwhelming, it's very, very hard to compete. On the other hand, if you look towards the future, this is the stuff that has to be exploited. Because there are swaths of it all over the place, essentially. Okay? I'm not going to say more about that. Okay. So you start looking at this cloud stuff, and you have central facilities, huge things that are going to be built. But I can tell you, all the orchestration to make this work, to make it work for the things that are intended, make sure there's security that goes along with it, that there's some degree of efficiency, that you actually know what you're buying, what you're not buying, what are you paying for. Well, you come to something called the hype curve. Okay, Gartner put this out. They had this idea some time ago. So they took a look at, what's true for the cloud and what's not. And when you look at it, you start recognizing things. Email services, boy, that's been in the cloud forever. Okay, and it works for some reason, and people trust it. Okay, and they put some of their most precious thoughts in it. Okay. It's exposed in lots of ways, okay, but it's out there, okay. So there's something that works. How much can you generalize it? How much can you make people, feel comfortable with it? Okay. To the extreme, okay, and that is, hey, do I want my whole electrical system being run from the cloud so it is super efficient because I can optimize everything, okay, and somebody hacks it? Telematics, can I do that for cars and traffic control? Okay, lots and lots of issues, and usually these things go through, sort of this initial enthusiasm. It hits a fever pitch. The advertising and graphics guys go to town on it. Then you get the realization this is harder than we thought. Takes a while for the science and engineering to catch up. And then eventually you get some utility out of it. So if you look at stuff like cloud, definitely happening, but boy, there is an incredible amount of room for invention at this point in time. Okay, let me say a little bit about users. We used to worry about, and a lot of companies still do, okay, hey, if I put more bandwidth out there, is it going to get used? Okay. What I'm finding is the hunger is there and almost insatiable at this point. And I look at simple things of the following sort. I now have a camera on my phone. I'm clicking photographs all the time. I got a new application, I think it's from Microsoft, called PhotoSynth. Okay? And what it allows me to do is all of a sudden not just have a photograph, but I can capture a room, a scene, a panorama. Okay? I find myself, I'm clicking away, and I'm looking at my storage bills going up and up and up. Okay? Really pretty incredible. Okay? And, we're rat pats. We like to talk, we like to text, message, we like to share things. Okay? There's a fundamental set of networks that underlies all of that. Okay? Human eye built for resolution, sort of the brain loves this. Experimentation with 3D stuff right now. I think some of it will eventually get to quality. We want our stuff wherever we are, so I look at a simple application like Dropbox that all of a sudden allows me to carry my stuff with me. It doesn't do many other things. I don't even know why I trust it, but boy, the utility is so great that I know I can have it with me. Okay? So we do that. And the other thing is we like to keep the stuff forever. Okay? And, you know, I'm at an age where I sort of started looking at genealogy, where did my ancestors come from, all of that. You know, it's actually amazing what you start discovering. What's been digitized, okay, who's been recorded in a photograph, things of that sort. And the wish is, I wish they only did more of this. Okay? So this isn't on a personal side. This is happening on a fairly wide scale and really happening all over the world. The next thing is there are only 24 hours in a day, so how much of this can you do? Well, I tell you, that technological world is abetting us, because I now have dies with multiple processors on them. Apple will get there eventually, but I can now run, okay, and keep alive many processes at the same time on my device. Okay, sometimes it's junk, but boy, it keeps that network busy. Every one of those apps needs an update. What's my location? What's the time? What's the this? What's the that? Okay, I think this is going to go for a long time. Because, in fact, I think what got invented, okay, is a Swiss Army knife. Okay, when you start looking at all of the things that I can do on these smartphones, it's absolutely astounding. Okay, you know, yes, it's not practical at some point to have one because the tools get in the way. Okay, in fact, we're experiencing some of that. If you have to have the password and name that you use for every app, touch and feel, this and that, they get in the way also, okay? But they're there. It's extremely useful, okay? And the traffic it's generating is extremely useful, and it becomes part of everyday life all over the place. So, you know, when I look at this journey sort of in retrospect, you know, you start off with Morse and the telegraph. For those of you who are electrical engineers and know about the telegrapher's equation and things of that sort, okay, great device. Alexander Graham Bell comes along and says, you know, I got to think people can talk point to point. Why don't you, Western Union, take this on? They threw him out the door, okay? They couldn't imagine. They're not in that business, okay? We go from that to phones. I don't know how many of you had a multi-party phone. I had one in my place in upstate New York until recently. I'm actually surprised how recently. You know, the black phone, then the Princess came out. Wow, what a change, okay? You know, there's Marty Cooper with his little brick, and all of a sudden, you know, you have all kinds of stuff. Okay, I don't know what's next. But when I start looking at those technology curves, okay, it's going to be incredible, essentially. Okay, let me turn to a specific part of all of this, and that's a continent like Africa. Poverty, lots of problems. It's the fastest market for communication today. If you look at the build-out of fibers around Africa, absolutely astounding. Probably led by the guys from the oil industry and their needs. Satellite systems going up. Turns out, if you take a look at what's the largest enterprise in a typical African country, it may be the oil company first, okay, something in mining. Number 2 or number 3 is a telephone company. Tax rates of 50%. This is what they've run their governments on. Okay, the goods are expensive. But getting the stuff out there is absolutely astounding. It's the hottest market. You have a country like Somalia, no government, okay? Probably one of the most competitive cellular industries in the world. Okay? Everybody has it, from the bad guys to the good guys. Internet cafes, things of that sort. And it's making a tremendous difference in the world, because all of a sudden they can participate in an economy to begin with. Okay, that's more than 100 yards from where they are. Okay, it's the world economy in many respects. Okay, and it has the fastest growth rates economically, and because you have these communication systems and networks that are coming in. Makes a tremendous difference, essentially. So if you look at it, I used to plot this a little differently, but basically what you find is the access to communications really correlates very strongly with income. So this is income in dollars, GDP per head, essentially, and this is a semi-log connectivity measure. Makes a tremendous difference. Okay, so I think there is a tremendous amount of good that comes out of this at the same time. Now, when I look at this whole industry, it's no longer a communications industry. It's part of the ICT cluster, information communication technology, essentially. And at this point, it's around 4.5% of the world GDP, okay, and growing. Okay. But when you actually look at the most influential companies, over 10%, I think 12 out of the top 100 companies in the world are actually communication companies or equipment builders at this point in time. Okay? And when you look at the Bureau of Economic Analysis, jointly with IBM, developed something called hedonic indices, what they show for the last 3 decades of the growth that we've had, the new technology that comes out of this sector is responsible for roughly 2/3 of the growth that we've had. So while we may be in the dumps that we went through a rough time, I can tell you that this stuff has really had a profound impact on the world and will continue to do so. So what matters? Scale, I mentioned that before. I think tools for managing the complexity that we have and actually hiding it from most users because they aren't savvy enough. You know, I look at the U.S. population, maybe 6% of it is sort of equipped to deal with something technical. The rest isn't, okay? And by the way, that's not necessarily a bad thing. You know, 2% of our population grows all the food for the rest of us, plus a good part of the rest of the world. And I think in the technological area, something similar may be happening, okay? It's global in nature, and boy, it takes a lot of partnerships to make something work today, essentially. So, what else is important? I think this notion of platforms and frameworks. So if I take a look at who's been successful, who's really come to the fore, you know, I think of Apple. It's not the hardware, it's not the cool looks. I mean, it's not unimportant, but it's actually having an operating system that has a certain touch and feel, okay, and deals and hides the complexity, essentially. That's important. If I take a look at Google, something very similar. If I take a look at somebody like FedEx that I mentioned, okay, because they did all the complex stuff, they did all the hard logistics calculations, all of a sudden, I can have something I can count on delivered in a day or two, okay, change the habits of Americans in incredible ways, essentially. If you look at the corporate world, if I remember working on something like a proposal, having to deliver it, you know, you did it on a typewriter, you did 3 copies, and you had to take a horse and buggy and deliver it. It took forever, essentially. Okay. So if you, again, sort of take a look at it, I think the other notion is you got to start thinking about stuff end to end. So even if you're concentrating on a component, understanding the context in which it fits, where does it belong in the bigger scheme of things, why is it important, why is this the right component to work on, it's important to understand that, essentially. Okay. Let's see, what did we do here? So there is, I think, going to be incredible shakeout in this stuff, but also a lot of opportunities. And the first one is to say, you know, we've digitized a lot of stuff, and we think we're sort of in the middle of it. Again, gut feeling is we haven't scratched the surface. We haven't actually architected the systems. You know, at Telcordia, we did a lot of research on the digitized home. Everything was going to be connected. My predecessor, Bob Lucky, wrote a very funny article in IEEE Spectrum, why he didn't want his toaster on the internet. Okay. And he's correct in many respects. But on the other hand, when I look at the way we use energy, being able to control it the way we now control it in chips, okay, tremendous gains come out of being able to do stuff that's online, accessible, and actuatable, essentially, okay? And, you know, if I look at the early adopters, I look at education with the MOOCs, things of that sort. I look at automotive and transportation, the connected car, health services of various kinds, essentially, and the financial guys always get into this quite early. But lots and lots of examples, I think, where this stuff is heading in those things, okay? So, deep ecosystems, and I think what we also have to think of is how do you deal with networks of networks? What goes over the top? What should be purpose-built because it's a critical function, possibly? What should be public, private, or somewhere in between? I think a lot of national debate on those issues, essentially. So I'm going to say, you ain't seen nothing yet, and thank you.